Today we are going to discuss one of the most important tests in statistics, which is called two-sample Wilcoxon signed rank test. Now maybe you can ask yourself why we are now going back to testing, because we have finished with t-test almost 4 weeks ago, and the answer is that in statistics we have a special class of tests. They're called nonparametric tests, and those tests are used when the assumptions for the t-test or parametric tests are not met, which means we don't have normality. Populations are not normal. All right, so firstly, I will give a quick overview of what we have learned so far, then background concept of the test, when this test, Wilcoxon test, is appropriate to use, then overview of the procedure. We will make a brief comparison with the sign test. I'll go through one example, then we'll use some technology, how to use Wilcoxon test in SPSS, and a summary. So if we start with this tree that I gave you at the beginning of this class, almost 3 months ago, we can say that the most difficult and confusing thing for any student or researcher in the world is which particular procedure to use. Because in statistics, we can use two different or more different procedures on the same data and obtain different results. So what is the truth? For example, if we apply t-test, we can reject the null hypothesis. If we apply Wilcoxon test, we fail to reject the null hypothesis. So what is the truth? And that is why this is really very important and confusing. So this particular test, Wilcoxon, two-sample Wilcoxon test, is used in a case when you have two populations or two samples, and those two samples are dependent. What is the meaning of dependent samples? The synonyms are related samples or paired data. So we have data such that first element in the first sample is somehow related to the first element in the second sample. So those samples can be matched, or the second scenario is when you perform some experiment on the same people. So we call those data paired data. So if we have two related populations or two related samples or paired data, the question is, what are our choices? So we can choose t-test, parametric t-test, or we can apply non-parametric test. The problem with the non-parametric test that looks weird or strange to you is that in non-parametric test we don't use means, we use medians as a measure of center. So in the case of two samples, we can use sign test or we can use Wilcoxon test. And sign test is one of the simplest, as we saw in the previous class. Sign test is one of the simplest statistical tests. Unfortunately, it only converts original data into signs of plus or minus, so it is not really efficient. Much better test is Wilcoxon test, but this Wilcoxon test requires one additional assumption, and that is that the populations are symmetric, or better to say that the population of differences is symmetric. Background concept. So this test was discovered by Frank Wilcoxon in the 1945. Frank was displeased with the state of statistics. He didn't have obviously computers, and he was forced to run tests again and again. So he was looking for some simpler test, and he created tests based on ranks. So instead of applying tests on the original observations, his idea was to replace original observations with the ranks, and then to apply tests on the ranks. However, because we instead of original observations, we just use the ranks. Wilcoxon was thinking really that his test was not as good in comparison to the t-test. He was thinking that his test wasted information obtained by the sample, and that his test was rough and ready, quick and dirty, and so on. Fortunately, that is not the case. So this Wilcoxon test, and it was discovered by the end of the 20th century, in the case when populations are not normal. For example, we have skewed distributions, or we have distributions like this one, or any symmetrical distribution, then Wilcoxon test is much better than corresponding parametric t-test. All right, so let's now go on. What is a rank? Now, a rank is a rank of some elements in the sample is their position when we arrange the sample elements in the increasing order from the smallest to the largest. So the smallest observation will get rank 1, then the next one, then the next large rank 2, rank 3, and so on. If we have exactly the same observations, we will replace the ranks by the average rank. So let's say that we have the following situation. We have, for example, following observations: 2, 10, 10, 1, 25, and 1000. So here we have an outlier, and if you apply t-test to test something, the result will not be as good as you think, since this outlier will confuse the t-test. So what we're going to do now is to replace these original observations with their ranks. So the smallest observation is 1, it will be rank 1. The next one is 2, rank 2. Now comes 2 tenths. So they occupy third and fourth position. The average is 3.5, so 3.5, and 3.5. Now 3.5. Now we have 25 is rank. This is rank 5, and finally 1000 is rank 6. Now let's go through this lecture exercise. I would like you now to, if you are at home, to stop this video and try to rank these numbers in the second column, which represent the proportion of the students at for our math 1114 Introduction to Statistics class, and for the students in this lecture theater, could you please try to solve that with your teammates? Thank you. So the solution here goes as follows. The smallest observation is 1, rank 1. So 3 and 3 occupies second and third place. So this is 2.5, 2.5. Next comes biomedical science, which is rank 4. Secondary education 5, science 6, and health science 7. Now let's reflect and think when this test is appropriate to use. I'll give you one example, two examples. So the first example, the question is, does a particular drug slow reaction times? Because if it does, then government might require a warning label. So a simple random sample of 15 people were shown, was selected, and we have data in this table. The question is there a difference between these two, statistical significant difference between these two samples? Next example 2. Suppose that 6 patients have received treatment intended to lower the level of serum cholesterol. The results before and after are shown in the following table, and the question is there a significant difference or not? So this is the perfect case. This one and this one are perfect case for applying Wilcoxon sign-rank test. Conceptual overview of Wilcoxon test. So the first step will be to state the null and alternative hypothesis. And as I said, we'll be using medians. So the null hypothesis is the same as for the sign test, two sample sign test. Median of the first population is the same as the median of the second population. Alternative, those two medians are not the same. Of course, we can apply one-sided test as well. Now, speaking of the assumptions, the assumption of this test is that populations are symmetric. Population difference is symmetric, so it can be like this, or like that, and so on. So it is much less restrictive than normality. What is the heart of the procedure? What was the famous idea of Wilcoxon? So we have two samples before and after and data. So firstly, we are going to calculate differences for each of the pairs. Then we will find the absolute value of those differences. Absolute value, just ignore the negative sign. And then we'll rank this column with absolute values and return back the original sign. And this is called sign rank. So then we are going to calculate sum of positive and negative ranks and take the absolute values. And the test statistic is smaller of the absolute values of those two sums. Comparison with the sign test. So Wilcoxon test is much more powerful than the sign test because it takes into consideration the magnitude of the differences. Sign test, remember, just for sign test, it is only important to find the differences. Is it plus or is it minus? Now let's go for the following example. A reading center claims that students with speech problems will perform better on some standardized reading test after going through a special reading course offered by this center. And in the following table, scores for 6 students randomly selected before and after the course are given. And the question at the level of significance 0.05, is there enough evidence to conclude that student scores after the course are better than the scores before the course? And so these are the observations. And so we have two samples, two relative samples, situation before and after. And we are going to apply Wilcoxon test. So firstly, we are going to calculate differences. For example, 68 minus 65 is 3. So we can calculate after minus before, or before minus after, doesn't matter. Then absolute differences, rank, and signed ranks. So the sum of the negative ranks is negative 1 and positive 14. So we're going to ignore the sign, and the test statistic V plus equals 1. Now Wilcoxon sign rank test in SPSS. Let's see how we are going to do this. We are going to enter our data in two columns, before and after. Before and after. And then we will go to the analyze menu and select from the analyze menu, we're going to select nonparametric test, then related samples, or we can choose analyze, then nonparametric test, legacy dialogues, and two related samples. So SPSS will automatically assume that we want to apply Wilcoxon test. And then we select the data before and after and click on the OK button. And what we're looking for here is nothing else but but the p-value. So the p-value is 0.08, and that is the most important piece of information that we need here. So since p-value is 0.08, this is larger than 0.05, so we don't have enough evidence to reject the null hypothesis. The null hypothesis is that the median before is equal to the median after. All right, finally, I would like you now to stop, if you're at home, to stop this video, and for the students at this campus, could you please try to answer these 4 questions that are really important for the conceptual understanding functional knowledge. Okay, thank you. The first question, what is the difference between parametric and non-parametric test? The answer is that parametric test requires additional assumption that population or populations are normal. Non-parametric tests, they don't have that information. Is two-sample Wilcoxon test parametric or non-parametric? It is non-parametric. Why? Because it doesn't have assumption of normality. Second question, what is the difference between dependent and independent samples? Dependent samples, we are looking at the situation before and after. Independent samples are completely independent between themselves. Third question, when you should use two-sample Wilcoxon sign rank test in case of independent or dependent samples? And the answer is dependent samples, 2 dependent samples. And finally, what are the hypotheses? Here, the hypotheses are that the medians are equal. Thank you very much, and I'll see you next week to give an overview and to prepare for the exam.